All right, we're going to use Gauss-Jordan Elimination, which is just using row operations to solve a system of equations. We're going to go ahead and take a look at this system here. Okay, and remember that we have three different row operations we can use. So we can switch rows, multiply a row by a scalar, or we can multiply a row and then add it to another. We really can't do anything else besides that. It's basically the same rules as elimination. Okay. So I'm going to go ahead and write what we want and then what our row operation is going to be and then our matrix. We always need to have a row operation and our new matrix listed when we solve a system by hand using a matrix. So I took our system of equations and I wrote it as an augmented matrix. The next thing we want is to get this in position 1, 1. I want a 1 there. So I can see that in row 2, I have a 1, so I'm going to go ahead and just switch row 1 with row 2. So we write it row 1 switches with row 2. So row 1 becomes -1, -2, -3, and 0. And then 0, 2, 1, -8. Row 3 does not change. This is like writing our equations in any order. Okay. The next thing we want is to get a 0 in row 3, column 1. We actually wanted to get a 0 in row 2, column 1, but we already had one, so we're going to move on to row 3, column 1. So we are going to replace row 3. So I know I need to add something to row 3. And lucky for us, we have our opposite in row 1. So when I add 1 to -1, that's going to make a 0. Everything else stays the same. So I get 1, -2, -3, and 0 for row 1, and 0, 2, 1, -8 for row 2. Row 3 becomes 1 plus -1 is 0. -2 plus 1 is -1. -3 plus 2 is -1. And 0 plus 3 is 3. All right, next up, we need a 1 in A22. So that would be right here in the middle. And again, I can see there's a 1 in row 3. So I'm just going to switch row 2. I'm going to switch row 2 and row 3, but I am going to make row 3 negative. So row 1 doesn't change. And then row 2 becomes row 3. And then row 2 becomes row 3 but negative. So 0, +1, 1, and 3. And I've accomplished my 1 right there. Next up, I need a 0. So I'm going to go work downwards to eliminate my y variable. So I need to make this 2 into a 0. And usually when I make something into a 0, I'm going to add to another row. So I want to replace row 3. What do I need to add to row 3? Well, it kind of looks like I should add row 1 because -2 plus 2 is 0. But if I add 1 plus 0, then I get a 1, and that undoes the work that we've already done. We want to keep that a 0. So it's best to use row 2. So I'm going to add row 2, but I need to multiply it by -2 so that when I add them together, it cancels out that little 2 there. Okay. So what stays? 1 and 2, because the only thing that's being replaced is row 3. Okay. So now we're going to multiply row 2 by -2. It is not traditional to write the operation inside the matrix. I'm just showing you. So 0 times -2 is 0, plus 0 is 0. 1 times -2 plus 2 is 0. -2 plus 1 is negative 1. And 3 times negative, oh, this should be a negative 3. Yes, this should be a negative 3 because that was a positive. Okay, negative 3 times negative 2 is 6, plus negative 8 is negative 2. All right, next up on our wants is a 3, 3 to be a 1. So our goal is to get a diagonal 1s here so that we have 1x, 1y, and 1z. All right. So row 1, I can see that I already have a 1 here, so I'm just going to replace row 3 with negative row 3. So 0, 0, 1, and positive 2. And then I have 1, negative 2, negative 3, and 0. 0, 1, 1, and negative 3. I forgot to fix that one right there. So negative 3. All right, now we want to back substitute. I have 1z is equal to 2 from this row. So I want to eliminate this z from that equation. So we're going to have row 2 is going to need to be replaced. I'm going to add to row 3 since there's so many zeros in it. And all I need to do is multiply row 3 by negative 1 to add to row 2 to replace row 2. So I get 1, negative 2, negative 3, and 0. 0, 0, 1, and 2 for row 3 because it's not being replaced. And row 2 is being multiplied by negative 1 of row 3. Times negative 1, times negative 1, times negative 1. Okay, so 0 plus 0 is 0. 0 plus 1 is 1. Negative 1 plus 1 is 0. That's our goal. And 2 times negative 1 is negative 2 plus negative 3 is negative 5. All right, 2 more steps here. Now we're going for a 0 in A1, 2. So row 1, column 2. So what do we got? I need to replace row 1. So I'm going to take row 1. And again, since there's so many zeros there's too many zeros in row 3. There's nothing I can multiply row 3 by in column 2 to get rid of my negative 2. So I'm going to have to use row 2. And I need to multiply row 2 by negative 2. And so it by positive 2, excuse me, since my 2 is negative. So that it zeroes that out. What doesn't change? Well, it looks like we're only replacing row 1. We always replace only one row at a time so that we don't mess up. Okay. All right, so row 2 is being multiplied by 2. And then we're going to add it to row 1. So we get 2 times 0 plus 1, 1. 2 times 2 plus negative 2 is 0. 0 times 2 is 0 plus negative 3. And negative 10 plus 0 is negative 10. Last one, all we need is this one right here. Row 1, column 3 needs to become a 0 to eliminate that z variable. So we're replacing row 1. I'm going to add something to row 1. And what I'm going to do is use this equation since there's a 1 in my z value, so I can actually multiply something by it. So row 3 times negative 3 added to row 1. I go ahead and write all the rows that are not going to change so I don't mess it up. So row 2, row 3, and then row 1 becomes times negative 3, times negative 3, times negative 3, times negative 3. 0 plus 1 is 1. 0 plus 0 is 0. Negative 3. We needed to multiply by positive 3. My bad. Okay, so positive 3 times 3 is 0. And then 2 times 3 is 6 plus negative 10 is negative 4. So what do we see here? What I see is that x is equal to -4, and then I have 1y is equal to -5, and 1z is equal to 2. I can write this a bunch of different ways. I can write this as a vector. X, y, and z is equal to -4, -5, and 2. I can also write this as a coordinate. -4, -5, and 2, representing our x, y, and z. That's it. We will do more in class.